Hi everyone and welcome to my talk. Today I'm going to talk how we can make use of Gradle plugin to manage multi-module Android projects. But before I begin, let me do a quick introduction about myself. My name is Malvin Sutanto and I'm a software engineer at Wantedly, and we are based in Tokyo, Japan. So let's start our talk by first talking about multi-module setup in Android projects. When you first start the development of your Android app, you will typically start with a single module. This module is typically called an app module. But then as you develop your features and your application further, these modules becomes bigger, and then you will start to split your modules into smaller modules. You can have, for example, a data modules, a library modules, and then even feature modules. And recently, a lot more teams have been adopting this model of a multi-module setup for their Android projects. You can have a lot of benefits with this model. For example, you can have a faster build time, especially paired with Gradle cache and parallel builds. And also with smaller modules, it's easier for you to manage and work with your code base. You can also make use of new features from Google Play, like instant apps or dynamic feature modules. However, there are also a few issues with this setup. Each of the modules will require a build.gradle files, which means you will have duplicate build scripts across a lot of these modules. And maintaining these build files can sometimes become quite hard, especially if you have a large number of modules. Let's take a look at a typical build.gradle file. This build.gradle file is generated by Android Studio when you create a new library module. Inside it, you can declare Gradle plugins that you want to use. You can set specific build parameters for your project, and you can even declare external dependencies to third-party libraries. Imagine having to update a lot of these files, and this can become quite tedious very quickly. And that's why today I want to show you how we can create a Gradle plugin to simplify this build script. But before I talk about Gradle plugin, I think it's a good idea if we first talk about what is Gradle. Gradle, even though it's mainly used for Java-based projects, it's actually a generic build automation tools where you declare the input files that you can consume and then declare how you can generate an output files. Gradle makes use of tasks as its unit of work. An example of task can be compile Kotlin or compile Java task. And tasks can depend on other tasks to declare the ordering of the execution. Gradle have three build phases. The first phase is called the initialization phase, where Gradle sets up the environment and then check which modules to be included in the build. The next phase is called the configuration phase, where Gradle constructs and configures tasks dependencies required to build the project. And then the last phase is the execution phase, where Gradle runs the tasks that have been selected in the configuration phase. Gradle makes use of a configuration file called build.gradle, and this file is written in domain-specific language or DSL, and is available in both Groovy and Kotlin. Inside this file, you can declare and describe the build steps necessary to build your project. Each top-level block in a build.gradle file is called an extension block. Inside this block, you can set build parameters specific for your build step. And then you can simplify common conventions and build steps using Gradle plugins. So what is Gradle plugin? Gradle plugin extends the Gradle model by adding new configuration blocks and options using extensions. Gradle plugin also helps you to configure your project according to sets of conventions, but still allows each model or each modules to override the settings when necessary. Gradle plugin can create and add new tasks to the task dependency graph and then configure sensible build defaults or default build parameters for your project. Gradle plugin also can help you to apply specific configuration to your modules. For example, you may want a Gradle plugin to enforce test coverage on each of your modules. There are two types of Gradle plugins. The first type is called a script plugin. Script plugin is an additional build script that is located separately from your main build.gradle files, and it can either exist in a local file system or in a remote location. And you can apply multiple script plugins using the apply from and then specifying the location of that build script. The second type of a Gradle plugin is called a binary plugin. Inside it, you will write a class that will implement the plugin interface. And to apply a binary plugin on other modules, you will make use of the plugin ID. So today, we are going to talk more about binary plugin and how we can create one. But before we create the Gradle plugins, maybe it's a good idea to define what will the Gradle plugin do for us. Of course, you can use Gradle plugin for a lot of different purposes, depending on your requirements. But today, I'm going to pick a few features that I think will give you an idea of what Gradle plugin can do. Our Gradle plugin will be applied on top of the Android Gradle plugin. And for each module, it will first apply other required Gradle plugins, for example, Kotlin Android plugins. It will then set common Android build parameters across different modules like SDK versions. It will also specify default program rules files for application and library modules. Program files are used to declare the rules to obfuscate your code. Then inside the Gradle plugin, I will also want to enable Java 8 language features on each of the modules, and then also declare any other external third-party libraries that are useful for my modules. And then finally, we will use the Gradle plugin to set up code coverage for each module using Jacoco, and then make this configurable using the custom extension. So this is roughly how our build.gradle files will look like after we apply our plugin. As I mentioned before, we will apply our plugin on top of the Android Gradle plugin, and then allows each module to override necessary settings using the DSL that we are all familiar with. I will also provide a custom DSL block to configure our Gradle plugin, and then I will declare any other additional dependencies to third-party libraries. Compare this with a typical build.gradle files. Our build.gradle files are now much shorter. Before we are able to develop a Gradle plugin, we need to first set up our project so that we can develop a Gradle plugin. To do that, in your project's root folder, you will create a build.src folder. And inside it, you will put a build.gradle.kts file. This is how the content of the file looks like. At the top here, I declare additional Gradle plugins that I want to use. The first one is Java Gradle plugin, which is a plugin that will apply the required dependencies and configurations needed for you to develop a Gradle plugin. And then I will also add the Kotlin DSL plugin. This is an optional plugin only if you want to make use of Kotlin script or KTS files for your build scripts. Then I will also declare any additional dependencies. For example, here, I declare dependencies to Android Gradle plugin. This Android Gradle plugin will allow me to work and refer to Android plugin related classes. AGP version here refers to the Android Studio version that you are using. So for example, if you are using Android Studio 4.1.0, here you will put 4.1.0. But this will only apply up until Gradle or up until Android Studio 4.2. Because for Gradle 7.0 and above, you will have to align to the minimum Gradle version supported by Android Gradle plugin. You can read more about it on the links that I put on the slides here. Then I will also declare dependencies to the Kotlin Gradle plugin, which will allow me to work with Kotlin-related tasks. Next, let's create the class that will implement the plugin interface. Inside the build src folder, I will create a src/main folder, and then inside it, I will create a class that will implement the plugin interface. So plugin interface has a generic type argument of project. So this project actually refers to a module inside your project. Then I will override the apply function. This apply function will be executed when a project's build.gradle file is executed in the configuration phase. And the project that is passed in here is actually refers to the modules that applied your plugin. And this will be the entry point to our build logic inside the Gradle plugin. Now let's implement the features that we want out of the Gradle plugin. The first one being that I want the Gradle plugin to apply other necessary Gradle plugins. So inside the apply function, I will call project.plugins.apply and then pass in the plugin ID that I want to be applied. This is actually very similar with how you declare additional plugin in the top of your build.gradle files. Next, I want the Gradle plugin to set common Android build parameters for all types of modules. To do that, I will first get a reference to the Android block because, as you have remembered, our plugin will be applied on top of the Android Gradle plugin. So an Android block here refers to the Android block in your build.gradle files. Next, I will check if that extension is of type base extension, because base extension is the base class for all Android plugin extension classes. And using this, it will allow me to set common build settings for all types of modules. So inside my function, I will set the build parameters as I want. And if you compare it with how we set it in a build.gradle files written in Groovy or Kotlin, this is actually very similar. Next, I want the Gradle plugin to specify the default program rules files for obfuscation. There are different types of modules in Android, but the most common ones are application modules and library modules. For an application modules, I want the Gradle plugin to enable obfuscation only on release build, and then specify any additional program rules files using the program files function. Whereas for a library modules, I want to specify the program rules files using the consumer program files. To do that, again, inside the apply function, I will create an extension function called apply program settings. Inside it, I will declare the program file names that I want to use. This will automatically pick up the program rules.profiles in each module's root as the program files to be used. And then I check if this type is of library extension, which means this is a library modules that apply the com.android.library plugin ID. Then I will set the program files using the consumer program files. Compare it with how we do it in our build.gradle files. Again, you'll see that this is actually very similar. Next, for an app extension, which means this is a module that applies the com.android.application plugin ID or an application module, I will enable obfuscation only on release build, and then specify additional program files using the program files function. So with this setup, the Gradle plugin will actually set up the correct program files regardless of whether the module is an application module or a library module. Next, I want the Gradle plugin to also apply or enable Java 8 language features. To do that, again inside the apply function, I will create an extension function called enable Java 8. And inside it, I will first set the source and target compatibility for Java code to Java version 1.8. Whereas for Kotlin compatibility, I need to get the Kotlin compile task that is available under the Kotlin Gradle DSL dependencies, and then set the compatibility using the Kotlin options. If you compare it with how we do it in build.gradle files, this is a build.gradle files written in Groovy, this is slightly different. Now, I also want the Gradle plugin to enable new Java language APIs using library desugaring. And to do that, I will set the isCore library desugaring enabled flag to true. But this is not enough, because to use new Java language APIs, we also need to add the additional dependencies to the library desugaring artifacts, to the project's dependencies, or to the module's dependencies. And this is actually what we can also do with Gradle plugin. So inside the Gradle plugin, I can add the library desugaring artifact to the core library desugaring configuration name. This configuration name is not very common, but as you might have noticed, this is actually similar to how we declare any additional dependencies to third-party libraries in modules written in Gradle. So you can also add dependencies to other artifacts, to other configuration names. For example, here I added the core KTX, the implementation configuration, JUnit to test implementation, and so on and so forth. Next, let's see how we can configure code coverage using Jacoco and make this configurable using custom extension. Creating an extension block is one of the benefits of creating a binary plugin over a script plugin. For example, here I created a custom extension block that will hold the Jacoco.isEnabled flag. So when this flag is enabled, I will set up the code coverage task and the dependencies around it. Before we are able to use a custom extensions, we first need to register the extension using projects.extensions.create, and then pass in the extension class as the generic type argument to that function. I will show you the content of this class in a bit. Then I will also pass in my plugin options as the extension block name. So this extension block name will be the extension of, the block that you will use in your the build.gradle files. And this is how the extension class looks like. Inside it, you will declare the configurable parameters that will be used by your plugin. And also, as you might notice, I need to mark this extension class as open, because Gradle will create a subclass of my extension class. Next, I will also create a simple class to hold Jacoco-related options called Jacoco options. And inside it, I will add a simple mutable Boolean flag to indicate whether I want to enable Jacoco for this module or not. I will make use of default arguments here because with Gradle plugins, you want to initialize your build parameters to sensible defaults so that you can make your build.gradle files a lot shorter. Next, I will also create a function that will represent our nested block. Here, I will make use of the action class that is available under the Gradle's Groovy DSL API. The reason that I want to make use of this action class is because I want this nested block to be available both under build.gradle files written in Kotlin and build.gradle files written in Groovy. If I have used function reference here, my nested block will only be available for build.gradle files written in Kotlin. So now with this setup, whenever I set this isEnabled flag from my build.gradle files, it will actually update the values inside the Jacoco options class. The example that I've given you here is configuration with simple classes and variables. For more complex types and APIs, you can take a look at the links that I put on the slides here. Now let's see how we can read and make use of the values that has been set using custom extension in each module's build.gradle files. To do that, I will create an extension function called configure Jacoco. And inside it, I will first call project.afterEvaluate. This is actually very important because the values that is set to your custom extensions will only be available after your build.gradle files have been evaluated in the configuration phase. And then inside the after evaluate block, I will get a reference to the custom extensions that we have created. Here I use extensions.getByType, but this is actually also very similar with how we got the reference to the Android block previously. So you can definitely use project.getExtensions.getByName here. Then because I call this inside the after evaluate block, the value that is reflected inside the isEnabled flag will be the values that is set in my build.gradle files. So when Jacoco is enabled, I first want to apply a Jacoco plugin, which is a standalone plugin which contains all the tasks and configuration needed to generate code coverage for your module. And then for a library modules, I want to make use of the library variants. And for an application modules, I want to make use of the application variants. This variants will be important because for a library, you have a debug and release variants, whereas for an application modules, you have not only debug and release, but you also have flavor debug and flavor release variants. And these variants will be important to set up the correct Jacoco tasks later. So inside the configure Jacoco task, I will first go through all the variants that have been passed in, including all build types and flavors. And then inside it, I will filter the variants that I want. So as an example here, I will skip a release build, which means I don't want to generate code coverage for a release build. And as I mentioned before, with Gradle plugin, you can create and add task to the task dependency graph. So here I will register a Jacoco report task that is responsible to generate code coverage for modules. And then, depending on the variants that I have passed in, I will generate the correct Jacoco task for that modules. For example, with this setup, I will generate Jacoco debug report task for my library modules, and then Jacoco flavor debug report task for my application modules. And then now I can set up the rest of the Jacoco task. For example, you can set up the task dependencies such that your Jacoco report task will be run only after unit test tasks have been executed. You can also set up the report files location, file filters, and file exclusions, and you can even make use of your custom extensions to make each of these parameters configurable. Now let's see how we can apply the Gradle plugins that we have created on other modules. Before we are able to apply our Gradle plugins, we need to first register it. So inside the build.gradle.kts files that we previously created inside the build src folder, I will add a Gradle plugin block, and inside it register the plugin that we've just created. The ID here refers to the plugin ID that you will use when you apply your plugin on other modules. And then the implementation class here refers to the full qualified name of your plugin. Now, after you've registered your plugin, you can now apply the plugin that you've created on other modules. Now, let's touch on the benefits of creating Gradle plugins and using it in your project. With Gradle plugin, you can share your build logic across modules, but still allow each of the modules to override the build logic when necessary. So this will reduce the maintenance costs associated with updating each of the build scripts. Gradle plugin also helps you to modularize your build scripts so that it's easier for you to manage and share your build scripts across different projects or different modules. Gradle plugin also helps you to encapsulate common build logics and enables you to declare build parameters to configure your build scripts instead of writing your build logic on build.gradle files of each modules. This will make your build.gradle files a lot slimmer. The other benefits that we felt when we implemented this model in our project is that Gradle plugin will help you to migrate your files from or migrate your build.gradle files from Groovy to Kotlin. Because as I mentioned before, if you make use of the Gradle's Groovy DSL API, you can apply your custom extensions for both Gradle files written in Groovy and Kotlin. Then you can gradually migrate your build.gradle files from Groovy to Kotlin. Let me show you an example. Let's say you have this very long build.gradle files written in Groovy. First, you will apply your plugin so that your build.gradle files is now much shorter. Now, with this much shorter build.gradle files, it's easier for you to migrate your build.gradle files to Kotlin. And you can even do this by module, so you don't have to migrate everything at once. The Gradle plugin that I showed you here today is a bundled plugin inside the build SRC folder, but you can definitely create a standalone plugin, which means a plugin that is developed on a separate project and then can be applied on other projects. But in my opinion, the plugin that I've showed you today is very specific for each project. But you can definitely split your plugins depending on its purposes. For example, we separated Jacoco as its own plugin because Jacoco has its own parameters around task dependencies, code exclusion, report formats. So it actually makes sense to split them as a standalone or as a separate plugin. And to summarize what I've talked today, maintaining build.gradle files can be tedious, especially if you have large number of modules, because you will have duplicated build logics and build parameters across of these files. And Gradle plugin can simplify the maintenance process of these files by encapsulating the build logic and allowing you to share build logics, and also enables you to enforce specific standards on each of these modules. You can even make your Gradle plugin configurable using custom extensions so that each modules can override the build parameters when they see necessary. And I think that's all I have for today. If you have any questions, feel free to ask me, because we are going to move to the Q&A sessions now. Okay, I guess we have one question here. What is the purpose of Jacoco using in Gradle? The purpose of Jacoco is to generate code coverage report, and Jacoco provides a separate Gradle plugin that you can use in your build, in your build steps, so that you can generate code coverage for your modules. So Jacoco is actually a separate tools that's only used for generating code coverage. So they don't really have any relationship with Gradle. Can we also create some Gradle plugin in Java as well? Yes, definitely. You can even use Groovy if you want to create your Gradle plugin. So as long as it's a JVM-based language, I guess, correct me if I'm wrong, but definitely you can use Groovy, Java, and Kotlin. What is the practical start limit to use this? How many modules? Definitely, if you have more modules, this becomes more beneficial. But I guess if you start to feel like updating build.gradle files becomes tedious, I guess that's a good point to start. I'm not sure if there's any hard numbers because it depends on the setup of your project. If you don't update your build.gradle files as often, I don't see the benefits of doing this. But once you go past certain numbers of modules, then you have to update your modules like in large numbers. That becomes very difficult. Next, great talk. Thank you very much. Is using the Gradle plugin improving build speed at all? I don't think there's any effect on build speed. Actually, I don't think it's going to even make it slower or make it faster, because if you remember, this Gradle plugin is actually an extension of your build scripts. So whatever you do in your build scripts or in your Gradle plugin, I guess, will actually doesn't impact the build speed a lot. Next question, can I get the slide because I got connection issue? Actually, I already put the link to the slides inside on the speaker blog, so you can go there and then get a link to the slides. Next, great talk, thank you very much. Do we use plugin as a tool to manage the versions of libraries across multiple modules? For this, it's a good question, because we actually tried to do something like this. Because for example, for RxJava, you will implement different artifacts, or I guess you will import multiple artifacts, and then you need to manage the versions of it. But we felt that after implementing this, it's even harder to manage the versions, because now the versions is not transparent to the developers, and also there's like a bit of a with interaction with IntelliJ and Android Studio. So I will actually advise you I will actually advise you against. I actually advise you to not use it actually. See if you have any more questions. Or if we don't have any more questions, I guess we can end it early. If you have any other question, feel free to contact me on Twitter or somewhere else, maybe on my Medium as well. And I guess that's all. Thank you. Bye-bye.